KCET 2026 aspirants, so welcome back to the Sankalp series where we have taken the pledge that we will work every day, put all our efforts every single day to get the top 1000 rank in KCET 2026 examination. Now, as you have seen this year, if you have just gone through the news or gone through the reactions of students after the KCET 2025 results were out, the most, I can say, common thing was students rank what they expected, they got below than that. Okay, the main reason that was discussed or that was given here was the students' performance have increased or have improved a lot. Many students got 290 plus in their board examinations, 150 plus in KCET examination. So this because the KCET exam paper was slightly easy this time. Okay, so it is like the competition has become very tough now. Okay, so it is now our duty to also upgrade our preparation. We cannot just be solving the last 10 years of PYQs and be sufficient. Okay, so that will not work now. So to just push your preparation to make it better, I have brought today some JEE PYQs of the year 2025 from the chapter Haloalkanes and Haloarenes. Okay, so the purpose of doing this is, first purpose is, many of you are also writing JEE examination, I know that. So solving PYQs will give you a confidence whether you have understood that chapter properly or not, and whether you are able to solve the JEE questions. And the second purpose here is, even if the KCET paper comes slightly difficult or slightly out of the box questions are come, you will be still able to solve it, because JEE questions will take your mindset in such a way, will make you think in a different way. The approach will be different while solving these questions. Okay, so these are the two main purposes of solving JEE questions, even if this series is completely dedicated for KCET 2026 examination. So now we will have here the first thing that I have always told you. Please always, we are putting a lot of efforts in making these videos, okay, recording for so much time, so that this 1 hour video which you see, there is a hard work of 4 to 5 hours like behind that. So when you give your response, when you put down your comments, when you appreciate us, or when you answer the questions, when you understand the concept, so that is the biggest reward that we get in terms of our hard work. Okay, so I have always asked you to please put down your homework questions, answers, or to just to give whatever questions are being asked throughout this session. You can put those answers, whatever you feel, you can express it in the comment section. So many students are doing that, but I want more people to participate. And some students have shown consistent efforts from the last like 4 or 5 classes, which has really touched my heart. And I definitely want to take a moment to appreciate, to congratulate, and to just recognize these students. Okay, I have been doing this from so many videos, but we'll be again seeing today's students here. So there are so many again comments, some new students I find every week, but there are 2-3 students who have been very consistent in all the videos. So first is here Hussein's comment. He has got 11 out of 15. So I remember that there were 30 questions in KCET examination, KCET video, and I told you that after 15 questions, please put down a comment how much you have scored. So I think that time he has commented this one. So thank you so much, Hussein. And 11 out of 15 by just one reading of the chapter is a super mark, and you can definitely improve more. Next we have from Bhuvan. So he has scored 26 out of 30. So thank you, ma'am. So Bhuvan, I am very proud of you, and I always, whenever I see the comment section, there is definitely a comment from your name, and that is something which keeps me motivated, and I just remind, okay, this student is consistent throughout all the sessions, all the videos I see his name. So that is why again congratulations to you. And this level of consistency, if you show throughout this 1 year, then I can guarantee you that you will be getting the top college of Karnataka. So we have 26 out of 30. Again, by first one reading you have done this much great. If you just practice more, we can achieve 30 on 30 also. So there are so many comments from Hussein. Hussein also has given one more comment regarding steric hindrance. The answer I have asked from question number 19. Then homework questions are posted by Bhuvan. So I remember last class I have told to Bhuvan and Sagar to post the homework questions also. So he has posted. We will see all the homework questions as well. Okay, so whether the answers are correct or not, I will tell you. Then we have a new student here, Revati. She has answered one question, benzyl halide. Okay, so that is really good. So I can understand when you do this typing in the comment section and then doing in your notebook, it takes a lot of time. It is difficult also, but still Revati, you have taken this effort to type the answer in the comment section. So kudos to you, and I am really I can say overwhelmed by seeing this effort. Next we have Hussein. Ma'am, I got 20 out of 30 and I'm very thankful for your teaching. So Hussein, that's also great mark, 20 out of 30. You will definitely improve. Just keep practicing, and I'm also very grateful that I'm also very thankful that I have got such beautiful and such honest and consistent students with me, and I'll definitely help you to get a very good rank in future. And we have also Hussein, one more question is answered, how the enantiomers different, what is the one physical property in which the enantiomers differ. That was the question, and they differ only in the rotation of plane polarized light. So absolutely correct, dear, this is the correct answer. Next we have Sagar. I scored 25 from your teaching my progress. So Sagar, you are also a consistent student. I have seen you from the very first lesson of I have noticed you from very first lesson of haloalkanes and haloarenes. So consistency is something which beats everything, whether you have higher IQ or not, whether you are intelligent or not, but if you are consistent, you can beat everyone. So I can see the progress has gone higher, so that is really nice. So every day we should be improving ourselves by at least 1%. We should try to do something good, something better, and improve each and every day. And this small efforts that we are taking today will result one day into great fruit. Okay, so yes, so these are all my champions today. So now we will be discussing the homework questions that I have given in the last class. So the combination which produces tert-butyl alcohol when treated with Grignard reagent. So this was, I can say, a little bit tough question. Little bit tough, not very tough. Okay, slightly tough question. But when you read the chapter aldehydes, ketones and carboxylic acid, this reaction becomes this question is a very super easy question. But till now, if we have studied only haloalkanes and haloarenes, then this question is slightly on the tougher side. So if I see the first one, I have to produce tert-butyl alcohol, right? So that is this one. Okay, now the question is which combination will produce that product. So if I see option number A, I have CH3MgBr, okay, plus CH3COCH3. Okay, so now this is delta plus and this is delta minus. Right, we know this one. And here if I see this, we will study in detail, very much in detail in aldehydes and ketones. But if you see this bond, okay, oxygen is electronegative, so it will have delta negative charge. Since this is having delta negative, carbon will have delta positive charge. So what will happen? This negative one will attack here. Okay, so what I will get here? CH3COMgBr. Then I have CH3 and then I have CH3. Okay, now if I do hydrolysis, this OMgBr is converted to OH. Okay, with hydrolysis, this is what we will get, that is tertiary butyl alcohol. So the first reaction itself will give you the product. So answer will be option number A here. Okay. Moving to the second homework question, the reaction between chloroethane and potassium hydroxide is a dash order reaction. Chloroethane, that is chloroethane plus potassium hydroxide. Okay, now see here, if you are reacting this one with this way, so this is a primary halide, so what will happen? We will get a product like this. Okay, we'll get a product like this, that Cl is replaced with OH group. Now what happens, now this is there, you have to think that this is a primary group, so that means it follows which reaction mechanism? SN2 reaction mechanism, and SN2 reaction mechanism is a second order kinetics, so that is why option C is the correct answer here. Okay. Moving to the third question, identify Z in the following reaction. So C2H5I alcoholic KOH, so that is elimination reaction. So what will be my X? So what is my X here? X will be CH2 double bond CH2. Then Br2 if you use, what will happen? This bond will break and bromine will be attached. So you have CH2, CH2, Br, Br. Okay, next what will be there? KCN. If you add KCN, this bromine will be replaced with CN group. So I have CH2, CH2, CN and CN. Okay, so that will give me what? Option number B here. Clear? Okay. Moving to now today's JEE questions, we will start. These all are 24 and 25 questions. Okay, so mostly 25 questions are there, some 1 or 2 24 questions are also there. But I am telling you, if you are able to solve these questions also, you can say that you have mastered this chapter. Okay, so the rule is very same like the previous KCET test. So there are total 24 questions. Okay, you have to see the question, pause the video, answer it in your notebook, okay, and then go for the next question. Okay, but here the marking system is slightly different. For every correct answer, if you are getting or if you are giving correct answer, give +4 to yourself. Okay, so there are 24 questions, means what is the total mark for this test? We have 96 marks. Okay, so for every correct answer you have to give +4, and if you do a wrong question, okay, then you have to do -1. Okay, and if for this rule is there for MCQ questions. Okay, for all I have written MCQ for this, which is a MCQ type question. So you have to do this format there. And there is one, I think one question which is of numerical answer type, means you have to write a number there. For that, for correct answer you will definitely get +4, but if the answer is wrong, okay, then there is no negative marking, means if answer is wrong you will get 0 marks simply. Okay, so there is no negative marking here. Okay, so you are clear with the marking scheme. So you have to first do all the questions correct or wrong, you have to check. After that, how many correct questions you have done, you have to multiply with 4 to get the answer, like to get your marks. Then how many wrongs you have done. From that, suppose you have done 5 wrong. So from this value which you have calculated, you have to subtract 5, because there is 1 negative mark for every wrong answer. Okay, so the game is little bit tough here, but let's see how much you are getting the score out of 96. See, you may get very less score, okay, but do not forget that this is something just a practice session. Okay, the more you do correct, the more you practice, you will improve. Clear? So let's move to the first question here. Okay, the example of vinylic halide is very easy question. Please take your time and do. So vinylic halide means what? Whenever I have, whenever you have a X group attached to one sp2 carbon, right? That is your vinylic halides. Now let's see where it is there. If I see the first one, this carbon is sp2. How to know sp2? Somebody has asked in the doubt section, I have seen. So you have to see how many sigma bonds this carbon is having. 1, 2 and 3. 3 sigma bonds, right? If the 3 sigma bonds are there, then the hybridization is sp2. If I have 4 sigma bonds, then the hybridization is sp3. If you have 2 sigma bonds, then the hybridization is sp. Okay, so now if I see each of these options, this particular carbon, okay, this is having 1 sigma bond here, 1 sigma bond here, and the H is also there, which is not shown. Okay, when you do bond line formulas, H is not represented. So this carbon is sp2 hybridized, and to that X is attached. So yes, this is a vinylic carbon. Next, if I see here, this carbon is having 1 bond here, 1 bond with X, and the 2 other bonds are with hydrogen. So this carbon is sp3 hybridized, so it is not a vinylic carbon. If I see this carbon, okay, so it has this bond here, this bond here, this bond here, and this bond here, 4 sigma bonds. This is also sp3 hybridized, so this is also not vinylic. Now if you see here, This carbon is, yes, definitely this carbon is having 3 sigma bonds. It is sp2, but this is not vinylic, this is aryl. Okay, so when the halogen is directly attached to the benzene ring, we call it as a haloarene. Okay, or you can say aryl, haloarene. Okay, this is haloarene or arylic bond. Okay, this is not vinylic. So correct answer for this question will be option number A. Next, moving to the second question, here we have, given below are two statements labeled, one is labeled as assertion and the other is labeled as reason. So assertion given to you is this particular compound CH2 double bond CH2Cl is an example of allylic halide, and the reason here is the allylic halides are the compounds in which the halogen is attached to sp2 hybridized carbon atom. So now please read the statement. So in the light of the two above statements, choose the most appropriate answer. Assertion is true, reason is false. Both assertion and reason are true, and reason is not the correct explanation of assertion. Assertion is false but reason is true. Assertion and reason both are true and reason is the explanation of assertion. So let's see both the statement. So is this an allylic halide? So definitely yes, because this is a double bond to the next carbon, chlorine is attached, so this is an allylic halide. Okay, definitely this is correct. Next is, what is the hybridization of this carbon? If you see, this carbon has 2 hydrogens like this, okay, one side chlorine, one side carbon, so 4 sigma bonds are there, so it is sp3 hybridized. So chlorine is attached to one sp3 hybridized carbon, right? But here the statement is saying allyl halides are the compounds in which the halogen is attached to sp2 hybridized carbon. So is it sp2 hybridized? No, it is sp3 hybridized. So this is false and this is true. So assertion is true but reason is false is my answer, which is option number A. Okay, if you have got both the questions correct, give 4 mark to yourself. Next we'll go to the the second topic, that is preparations of haloalkanes and haloarenes. The first question here is, propane molecule on chlorination undergo photochemical condition gives 2 dichloro products X and Y. Amongst the X and Y, X is an optically active molecule. So you have propane, right? That means I have 3 carbons. Now when it was done chlorination under photochemical conditions, 2 dichloro products were formed. Okay, there were 2 dichloro products formed. So we can have one dichloro product like this. I can have a chlorine here and I can have a chlorine here. This is one possibility. You can have one dichloro product like this also. Okay, one more I can get actually. I can also have a product like this. Okay, so they are saying any 2 of this is formed. Okay, we don't know which 2 is formed, but 2 products are formed. Amongst X and Y, X is an optically active molecule. So which is optically active out of this? So how to find whether it is optically active or not? So for optical activity, you should have, carbon should have 4 different groups attached. Okay, the carbon should have 4 different groups attached to the to itself. Now if I see here, in this particular carbon, this is having 3H, so all the 4 groups are not different. Here we have 2 hydrogen, this is also not different. Here also we have 2 chlorine, so this is also not different. Next, if I talk about this one, here I have CH3 and here I have CH3. So this carbon is not having 4 different groups, this carbon is not having 4 different groups, this carbon is also not having 4 different groups, so this is also not optically active. Now if I see here, okay, just let me write down all the numbers. Okay, now if you see, this carbon is having 2 hydrogens, so this is not optically active. But if I look at this carbon, this is having H and Cl, and here you have CH3 and here you have CH2Cl. So this carbon is having all the 4 groups different. So that is why this can be an optically active compound. Now coming to this one, here we have 3 hydrogens. This also is not optically active, but since this carbon is present, which is a chiral carbon, the whole molecule is what? Optically active. Okay. Now let's read the next question. So this is my X. I can understood that the X is someone which is optically active. So this is X. So amongst X and Y, X is an optically active molecule. Next question is, how many trichloro products will be obtained from X when it is further treated with chlorine under the photochemical condition. Okay, so you are further giving chlorine to this one. So how many different trichloro products can be formed? So let's see that. So I'll erase these all things. So what X I got? X is CH3. So I'm writing like this so I can show you all the bond. So X is like this. Okay, now trichloro product means you have to bring one more chlorine and you should get different products. So if you replace this hydrogen with chlorine, you will get one product. Okay, so 1, 2 and 3, that will be one product. So what I will get here, that is CH3 CCl CH Cl Cl and H. Okay, that is one possibility. Another, so if you replace any of this hydrogen, you will get 3 carbons having 3 chlorine. That can also be a product. So I can have like this Cl, then you have HCl, then you have, okay, this is one product formed. Next what I can have is this hydrogen can be replaced with chlorine. Okay, this hydrogen can also be replaced with chlorine. So what I will get here, that is CH3 CCl Cl ClHH. Okay, 1, 2. So how many products I have got? See, if I replace both the chlorines here, that is one product that I have got. Second one is I replace this hydrogen, and third one is I have replaced this hydrogen. So total I am getting 3 different types of products. So option number A is the correct answer here. Okay, I hope this is clear. See, once again I'll tell you, this is my X already. So you cannot change anything here. This is the final product. Here you have to add chlorine at different positions and check how many different products you can get. So first I can change this hydrogen to chlorine, I'll get one product. I can change this hydrogen to chlorine, I'll get second product. I can change one hydrogen here to chlorine, I'll get 3 products. So total option A is the correct answer. Next we have, when secondary butyl cyclohexane reacts with bromine in presence of sunlight, the major product is. Okay, so when secondary butyl cyclohexane, so if you have secondary butyl cyclohexane reacts with bromine in the presence of sunlight. Okay, the major product is, so here if you know that when this reaction is happening, okay, so you have these hydrogens, one second, sorry, yeah, so we have these all hydrogens, these are all hydrogens which are having a possibility to be reacting with this one. Okay, so now what will happen, you will find that the one which is a more stable one, there the replacement will take place. Okay, so we can get bromine produced here. So if you see this hydrogen, if this hydrogen is replaced, which product will get? That option is not given. If I replace this hydrogen, then I'll get this product, but this is a secondary radical. But if you see here, this carbon is attached to 3 other carbons, so this is a tertiary group. So if here the bromine is replaced, that will give you the major product or the more stable product. So that will be your option number D here. Okay, so this is also secondary. Okay, this is also secondary, this is also there, but first the chain, the aliphatic chain will react. Okay, moving to the 5th question here, choose the correct set of rearrangements for the following conversion. Okay, you have ethyl benzene, you have ethyl benzene, and then it is giving you bromoethene. Yes, Okay, so now what will happen? So if I see the first option, Br2Fe, so what will that do? It will add a bromine to the ring. So if I follow this one, I will get, see, this is an alkyl group, this is electron donating group, right? So where the bromine will go? The bromine will go to the so now if let's see now question number 5 here. Choose the correct set of reagents for the following conversions. So we have here ethyl benzene, okay. So we have here ethyl benzene, okay, and then we have this another compound, that is so let's see the next question. Choose the correct set of reagents for the following reactions. So here we have ethyl benzene and then the product is given and you have to find the final product here. So if I see here, just a minute, yeah. So I have ethyl benzene, okay. So I have ethyl benzene and then the product here we have is we have here is CH double bond CH2 and Br, okay. So now here what will happen, this bromine, so we can have Br2 and Fe, okay. So you can have this bromine reacting with Fe, so that will give us what? You will have something like this, okay, and we have bromine here attached to the ring. So that is, I can have yeah, so bromine will now be attached to the ring and this is ortho para directing, so this one will be having Br here, okay. Now if here bromine is attached, then you have chlorine and heating. So if I do chlorine and heating, okay, so what will happen here? If you heat in the presence of chlorine, this is an photochemical reaction, okay. So the chlorine will be replaced either here or this hydrogen. This is primary hydrogen, this is secondary hydrogen, so definitely here there will be replacement. So I will get here, that is Br, and you will have CH, Cl and CH3, okay. And after that, if you use alcoholic KOH, so this bond will be removed and you will get something like this, okay. So double bond will be removed here and the double bond will be formed here and this will be the reaction. So correct answer here is option number A. Now moving to the next question, given below are two statements. Statement 1, alcohols are formed when alkyl chlorides are treated with aqueous potassium hydroxide by elimination reaction. So alcohols are formed when alkyl chlorides are treated with aqueous potassium hydroxide by elimination reaction. So the question here is saying that if you have alkyl chlorides, okay, and then if you treat it with aqueous potassium hydroxide, okay, you will get alcohols, okay. So now this is an elimination reaction. Is it an elimination reaction? So in elimination reaction, the product formed is always a double bond, okay, not a like it's not a, this is a substitution reaction where the X group has been replaced with the OH group. So that means what? This is which type of reaction? This is substitution reaction. So this statement is incorrect. Next, in alcoholic potassium hydroxide, alkyl chlorides forms alkenes by abstracting the hydrogen from the beta carbon. So if we have alcoholic potassium hydroxide, okay, in alcoholic potassium hydroxide, alkyl chlorides form alkenes by abstracting the hydrogen from the beta carbon. So if you have alkyl chlorides, for example, if you have alkyl chlorides, okay, if you have alkyl chlorides in presence of alcoholic potassium hydroxide, in presence of alcoholic potassium hydroxide, what will happen? Alkyl chlorides form alkenes. So what will this beta CH2 is there, this is there. So this OH minus, okay, will abstract this hydrogen and this one will form here and this one will go out. So we will get a double bond here, Okay, so alkenes is formed by abstracting the hydrogen from the beta carbon. So this statement is correct. Okay, statement 1 is incorrect, but statement 2 is definitely correct. So what will be the answer here? So we have statement 1 is incorrect, but statement 2 is correct. Do I have that? Statement and 1 both are incorrect. This is not there. Statement 1 is incorrect, but statement 2 is correct. Yes, that is the option number B. Okay. Next we have 7th question. Predict the major product of the following reaction sequence. So here we have toluene. Okay. Next, what we are doing here, Br2H nu. So here again, what will be the product? Here the bromine will come. Okay. So bromine will be produced. Bromine will be attacked here. See now, this is a primary carbon, this is a tertiary carbon. This hydrogen is tertiary hydrogen. So this one will be, the bromine will be replacing this hydrogen. Okay. Then when you have alcoholic KOH, okay, if you have alcoholic KOH, so there will be a double bond here removed. Okay. So alcoholic KOH is there, this double bond is formed, and then you have HBr with ROORH nu. Okay. So when I have HBr, okay, with H2O2 formation, so what we will get? We will get something where this is a peroxide linkage is formed. Okay, peroxide linkage. So you will get a bromine which is, so according to anti-Markovnikov rule, the bonding will take place. So what does this anti-Markovnikov rule tells you? The anti-Markovnikov rules tells you that the negative part will go to the carbon with less number of hydrogen, with more number of hydrogen. Why anti-Markovnikov rule? Because peroxide is there. So this is the group, right? So here, if you see, this carbon is having only one hydrogen, this carbon is having no hydrogen. So here the bromine will be attached. So I will get a compound like this. I'll get a compound like this. Okay, so what product is that? That is my option number B here. Okay, so that is option number B. Now we will have question number 8. In the following series of reactions, identify the major product A and B respectively. Okay, so if you have bromobenzene with SO3 H2SO4, what will happen? SO3H will be attached at the para product, right? Para position, because it is major product. So where here there is ortho substitution, here also ortho substitution, these are wrong. These two are correct because these are para substitution. Next we have Br2Fe. In FeBr2, what will happen? Bromine will be attached again at ortho and para position. But since here if you see the para position is already blocked, the bromine can attach only at the ortho position, not at the meta position. Okay, why? Because this is again ortho para directing, means all the incoming electrophiles will go to ortho and para position. The para position is already blocked by sulfate SO3H group, so only the ortho position is left. So bromine will be attached at the ortho position. So option number B here. Next, moving to 9th question, you have this 2-bromo 1, 2, 3, 4, 5. 2-bromopentane, alcoholic KOH is there, major product is formed, and then Br2 is added. Consider the above sequence of reactions. 150 gram of 2-bromopentane is made to react. The yield of the major product P is 80%, whereas the Q is 100%. Then what is the mass of Q obtained here? So this is not an MCQ question, this is a numerical type question. Okay, so first let us find the major product P and Q, and then we will decide. Okay, so when I do alcoholic KOH, what will happen? You have this group, right? So this H and Br will be removed. Here also H is there. This one can also be removed, this one can also be removed. But according to Seitzev rule, what will be the major product? The major product here P is this one. Okay, this is P, the major product. Now if I add Br2, okay, then what will happen? This is their Br and this is Br. Okay, so this is a Br group is attached, and here there is an alkene formed here. Okay, the question here is this P is 80% of the major product, means how much I can say? This is 0.8 mole. 80% is 0.8 mole. Now all this is converted to this product. Okay, this is 100% converted to this product. So that means this is also 0.8 mole. Okay, now once I know the moles, can I not convert it into mass? So very easily we can just convert it into moles, mass. So the mass of all the compounds are given. So here I have CH3, here I have CH2, here I have CH, here I have CH, and here I have CH3. So how many carbons? 1, 2, 3, 4, 5. Okay, so I have 12 into 5, 60 carbons are there. Then hydrogen 3, 4, 5, 6, 7, 8, 9, 10. So I have 10 into 1 hydrogen, that is 10 hydrogen is present. Next bromine, if you see there is 2 bromines here, 80 plus 80. So that is, I can say 80 into 2, which is 160. Okay, so I have 230 is the total mass. But what is the number of moles? 0.8. So if I convert it to mass, you have to just multiply with 0.8. So I have here 18, so 184 gram will be the answer here. So what is the mass of Q obtained? 184 grams. Now coming to the 10th question, very simple one, match the following question. So I think this is visible to all of you. So you have this reaction dry ether with a aryl benzene and you will get diphenyl. So this is your Fittig reaction. So here this is option number, this will match to 3. Next, if you see ArN2 plus X minus with HCl, you will get ArCl. So this is your Gattermann reaction. So this will match here. Then if you have iodine formation, this is Finkelstein reaction. So this you will match here. And then if you have HCl and ZnCl2, so this one will react with Lucas reagent. Okay. So I have A3. So I can remove these two options. Okay, with A3. And then with B you have 4, that is this one is also removed. I have option number B. Okay, next I have question number 11 here. An optically active alkyl halide C4H9Br reacts with hot KOH dissolved in ethanol and forms alkene B as a major product which reacts with bromine to give a dibromide C. Okay, so an optically active alkyl halide C4H9Br, okay, reacts with hot KOH dissolved in ethanol to form an alkene B. So here if you see C4 reacts with hot KOH in ethanol and forms alkene B as a major product. So now see, okay, here we have two possibilities. C4H9Br, we can also have this structure, right? Now if this one is treated with hot KOH in ethanol, you will get only one product where the alkene will form here. But if Br is present here, you have two product, one alkyl which will form here and the other possibility is here. Now if this one, this possibility and this possibility is there, this is the major product, this is the minor product, but here only one product is formed. The question is saying that you have a major product. Okay, alkene B is a major product, means there would be a minor product as well. So this has to be the alkene that we are talking about, because here major and minor will be there, here only single product is there. So what I can do now, so I have C4H9, what is my A then? This is A. Okay, after that when you have formed an alkene, you will get a compound like this. Okay, HBr, you will get a major product like this. Okay, then you will have a dibromide C. Okay, so this is B is formed here, and then if you have dibromide, you will get like this. Okay, the compound C is converted into a gas D upon reacting with alcoholic NaNH2. So if you have reaction with alcoholic NaNH2, then what will happen? There will be dibromide. This HBr will be removed, this HBr will be removed, and you will have like this. Okay, the compound C is converted into a gas D. So this is your compound D. upon reacting with alcoholic NaNH2. Now during hydration, 18 gram of water is added to 1 mole of gas. 18 gram of water means 1 mole of water is added. Okay, so here what will happen? This bond will break, H and OH will be attached. So you will have like this. Okay, now this one will come here and this one will come here, and then you will get a product like this, CH3, CH2, C double bond O, CH3. Okay, so what this is something called as tautomerism. Okay, if you have studied in the lower classes, this is a type of rearrangement called as tautomerism. Okay, so what will be the answer here? Butane, butane 2-ONE, that is option number C. Then we have 12th question here, statement based question. So statement 1 is CH3O, CH2O3 will undergo SN1 reaction though it is a primary halide. So now you see, if this bond goes, okay, here a cation will form. Now this cation is resonance stabilized due to this lone pair. So whenever carbocation is stabilized, it is forming SN1 reaction. So this is the SN1 reaction even though it is a primary halide. Now second one here, will not undergo SN2 reaction easily although it is a primary halide. Now this compound definitely is a primary halide, but you see here it is very bulky, right? Steric hindrance is there. So although it is a primary halide, it is very reluctant to undergo SN2 reaction because of steric hindrance. So here it is SN1, although it is a primary halide. Why? Because for SN1 what is the order? 3 degree, 2 degree, 1 degree. And for SN2 what is the order? 1 degree, 2 degree and 3 degree, right? So here SN1, this compound should not undergo SN1 because it is a primary halide, but you should also check that this carbocation is highly stable. Now this is primary halide, so it should undergo SN2, but it will not undergo because we have a very bulky compound near to it which is sterically hindered. So both the statements are correct, so we have option number B here. Okay. Moving to 13th question, you have to find the product. RBr is given, okay, and Mg dry ether is there. Then you will get after that hydrolysis is there to give you this product 2-methyl butane. Now the maximum number of RBr producing 2-methyl butane by above sequence of reaction is, consider the structural isomers only. So if you have RBr producing 2-methyl butane, so how many RBr can produce 2-methyl butane? Okay, so you have a compound like this. Okay, so now what all things we can make, what all things this RBr can be there to give you this product. Okay, so if I have Br here, for example I have bromine here, then when I treat it with MgBr, this one will become MgBr. After the hydrolysis I'll get this compound. This is one possibility. I can also have bromine here. Okay, so when I treat it with Mg dry ether, it will become MgBr, and then after hydrolysis this will become H. Okay, next I have I can replace, I have a bromine here also. Okay, so now this one can be treated with MgBr, and on hydrolysis you can remove this, I'll get this compound. Okay, that is a possibility here. And next we have next what I have possibility. Okay, I have one, so whether this one or this one, these both are same. Okay, so one possibility we'll get from here also. So total 1, 2, 3, and I have one more option, that is this bromine. Okay, 1, 2, 3, 4, which is option number A. Okay, moving to next, that is 14th question. Again, match the following. The match the following here is slightly confusing. So Schwartz reaction is what? Ethyl fluoride. So A has to be 4. I can eliminate these options. Next, Woods-Fittig reaction, Finkelstein reaction has to be an iodide group, right? So I know this will be, D will be 2, both here D is there. Next, Sandmeyer reaction. Okay, Sandmeyer reaction is actually what? When you convert this one, okay, to chlorobenzene or bromobenzene. But now what happens, this product we can also obtain from cyanobenzene. Okay, So I can relate Sandmeyer reaction to cyanobenzene. So B will be 3, and Woods reaction and Woods-Fittig reaction can be reacted with ethyl benzene. So I have option number C here. Okay. Next, moving to question number 15, the ascending order of the reactive rate of solvolysis of the following compounds. So for solvolysis, what is the order? I have 3 degree, 2 degree and 1 degree. Okay. So here if I see that, one second, yeah. So here if I see this one, this is which degree? 1, this is 3 degree, definitely. Okay. Next, this is 2 degree. Okay. This one is also 2 degree, this is 2 degree. Okay, but you have to check the stability of carbocation. If it is resonance stabilized, then it is also highly reactive. So I can see here that if this bromine goes out, this is resonance stabilized by 2 phenyl groups. Okay, resonance stabilized by 2 phenyl groups. So that is why I can say that C will be highly reactive. Next, if you see a carbocation is formed here, this one will react or this one will be resonance stabilized after this, okay, because here it is also resonance stabilized. So after C we will have B. Okay, so I'm getting this option only, but let's check here. Next, here this is a tertiary, so after that A will come, okay, and lastly D will come. So option number D is the correct answer here. Okay. Next, moving to the question number 16, the structure of the major product formed in the following reaction. This is very simple. If you have this one, these groups will not be replaced because they are directly attached to the ring. This Cl group can be replaced with isocyanide. AgCN gives you NC, right? So what I will get? Isocyanide, that is option number B here. Moving to 17th question, product A and B in the following reaction. Again a similar reaction. AgCN will give you what? NC. So B has to be NC. This cannot be there. This cannot be there. And AgNO2 gives you NO2 group, right? It gives you NO2 group. So this is NO2. So this already eliminated. This is giving you ONO. So this is not there. So I am left with this group where I have NO2 and NC. So option number D is the correct answer. Next, I have the product B formed in the following reaction sequence is, okay. So first of all, you have this compound that is a benzene ring, okay. So we have this one, and you have HCl group attached, okay. So now HCl is what? So now you see a carbocation form here, a carbocation can form here. Now this carbocation is also secondary, this carbocation is also secondary, but this carbocation is resonance stabilized. So that is why this is the carbocation formed here. So the negative part, that is chlorine, will go and attack here. So what will be the product here that I'll get? Cl is the product formed here. Next, AgCN, what will happen? This group will be converted to NC, okay. So here I will have okay, that will have NC here. So what will be the final answer here? That is my option number D. Okay. Next, moving to question number 19 here, the major product formed in the following reaction. Again, you have this bromine group, KOH excess is there, and then heating is there. So I have this group, one second, you have a benzene ring, okay, this is there, this is bromine and this is bromine. Now what will happen? When you give excess of KOH, what will happen? This bromine group will be replaced with OH group. Okay, so this one will be replaced with OH group. Okay, now when you heat it, so there will be dehydration reaction and a double bond will form. Now see, this double bond can form this side also, this side also. This double bond can form this side also, this side also. So here definitely there is more, I can say, this will be according to Seitzef rule. Here the bond will form because it is more stable, more number of carbon groups are present. So one bond will form here. Now this bond can form that side or can form this side. Both the groups are equally same. But here there is a rule that conjugation, if the double bonds are in conjugation, that system is highly stable. So conjugation means double bond, single bond, double bond, single bond. So if you see here in the benzene ring, just a minute. So here in the benzene ring you have a double bond, then a single bond, double bond, single bond, then this OH and H will be removed and we'll get a double bond here. Okay, fine. So this is a reaction, that this is a product that we will get. Now how can I number it? So we have 1, 2, 3, 4, 5, 6 and 7. 1, 2, 3, 4, 5, 6 and 7. Okay, so how can I name it? So 2-phenyl. Okay, so this is 2-phenyl, 2,4-2-phenyl hept. So how many ring is there? Hept. So 2-phenyl hept 2,4-diene. So option number A here. Moving to the next question, that is 20th question here. Which among the following halides will generate the most stable carbocation in the nucleophilic substitution reaction? So here if I have a carbocation, this will be highly stable because it is resonance stabilized. Here if I see, this is also resonance stabilized. Here if I remove, this is also resonance stabilized, but stabilization due to benzene will be more effective. But here if I see, there are 3,3-phenyl rings which will stabilize this ring. Okay, there are 3 phenyl groups which can stabilize this ring. So that is why the correct answer here will be option number D. Okay. Then moving to the next question, number 21, polyhalogen compounds. So if you have carbon tetrachloride, match list 1 with list 2. Okay, so when we have carbon tetrachloride, it is used as a fire extinguisher. So A has to be 3. Okay, so we have only one option with that, so that will be the correct answer. But let's see the other options as well. Methyl chloride is used as a paint remover, and then DDT is used as a non-biodegradable insecticides. Freons are used in the refrigerators. Okay, so this is the correct option. Moving to question number 22, again on the uses of polyhalogen compounds. So iodoform is used as an antiseptic. So A3, I have 2 options, I'll remove them. Then carbon tetrachloride, it is used as an fire extinguisher, just now we discussed. So B1 is there, so this will be the correct option. Chlorofluorocarbon is used in refrigerants, that is C4, and DDT is used as an insecticide, so D2. Okay. Next, moving to 23rd question, in the following hydrogenated organic compounds, the one with maximum number of chlorine atoms in its structure is. So for that you need to know the structure of all of them. So I have given you all the structure. So this is chloral atom, okay, the first one. So how many chlorine atoms are there? 3. This is gamexine, where I have 6 chlorine atoms. Next you have chloropicrin, which is also having 3, and then you have chlorofreon 12, which is having 2 carbons. So maximum number of chlorine atoms is present in gamexine, which is option number B. Next we have, which of the following compounds is an example of freon? So if I see freon is what? How can I explain freon? So freon is chlorofluorocarbon compounds. Okay, freon is chlorofluorocarbon compound. So here you have only fluorine, here you have fluorine, and here we have fluorine. But here we have both chlorine and fluorine. So option number A is the correct answer. Okay, so these are the questions of the JEE questions, and I think many of you would be able to solve it. So please, if you have any doubt in any question, do put down in the comment section. In the next class, I will explain it again with much more detail. Okay, any question you find you didn't understand, just put down in the comment section. And in today's class, there is no homework. And one more important thing is, many of your unit tests are starting. So for both PU1 and PU2, we are planning a session, a revision video for unit test. So what are your portions in the unit test, which chapters are there, and on which date you have chemistry examination, please put down in the comment section. Okay, so that's all in this video, students. Thank you for watching and all the best.